In this video, we're going to learn how to apply our knowledge of trig ratios to solve for missing side lengths in right triangles. This falls under a learning target. I can solve right triangles. Let's start with a little review. Notice that I have a right triangle and I have my theta placed. I'm going to start by labeling my opposite, adjacent, and hypotenuse. My hypotenuse is always my longest side, which is across from my 90-degree angle. Across from theta, the side across from theta is this one right here, so I'll label that as the opposite. And last but not least, we have our adjacent side. Okay, let's recap our three trig ratios. We have the sine of theta, which is equal to the opposite over the hypotenuse, the cosine of theta, which is equal to the adjacent over the hypotenuse, and the tangent of theta, which is equal to the opposite over adjacent. We can remember all of these ratios with the phrase so, ka, toa. In this first sample problem, we're asked to find for the missing side length x. I notice that I have a 31-degree angle and I have a 17-yard side length, and then I'm looking for x. I'm going to call my 31-degree angle theta, and I'm going to label my sides in terms of theta, so my opposite, adjacent, and hypotenuse. Okay, so my hypotenuse is x. It's always the longest side across from 90. My opposite side from theta is my 17 yards, and then the other side is my adjacent. I notice that I have things, or want to find things, with my opposite and hypotenuse. So if I recap and think of my SOHCAHTOA, I notice that I want to figure out something with O and H. So O and H, I'm dealing with so I'm thinking sine. So if we think the sine of theta is equal to the opposite over hypotenuse, from here we're going to plug some things in. So my theta is 31 degrees. And that's equal to my opposite, which is 17, over my hypotenuse, x. Okay, to solve for x, I'm going to put sine of 31 degrees over 1. Remember, if we type in sine of 31 degrees into our calculator, it's going to turn out to be some funky decimal, but it's a number. From here, I'm going to cross multiply. So I have 1 times 17, or 17, equals x times the sine of 31 degrees. I notice that to get x all by itself, I need to divide both sides by the sine of 31 degrees. And when I type that into my calculator, I end up with 33.01, and I'm dealing with yards here as my value for x. In this next problem, we're asked to solve for x again. I see my 22-degree angle, that's where I'm going to label my theta, and now in regards to theta, I'm going to label my opposite, adjacent, hypotenuse. My hypotenuse is x across from my 90-degree angle. The side across from 22 degrees, across from theta, that's my opposite. And then the other side is my adjacent. So keeping in mind my SOHCAHTOA, I notice that I want to figure out my hypotenuse, and I know my adjacent, so I'm focused in on the A and H. The item with the A and H, that's my ka, or my cosine. So I'm going to start with the cosine of theta is equal to the adjacent over the hypotenuse. And from here we're going to plug in. So we have the cosine of 22 degrees is equal to the adjacent, which is 18, over x, my hypotenuse. Okay, remember, if I type in cosine of 22 degrees, we're going to get a funky decimal, but it's a number. So I'm going to put cosine of 22 degrees over 1 so that I can cross multiply. And I'm left with x times the cosine of 22 degrees is equal to 18 times 1, or 18. To get x all by itself, I'm going to divide both sides by the cosine of 22 degrees. These reduce, and if I type in 18 divided by the cosine of 22 on my calculator, I end up with 19.41, and we're dealing with yards. In this last problem, we're also asked to solve for x. I'm going to label my 35-degree angle as theta, and label my sides in relationship to that theta. My hypotenuse is the longest side across from 90. The side across from 35 degrees, that's my opposite, so that's x. And my other side is my adjacent. So now if I think in terms of SOHCAHTOA, I notice that I want to figure out my opposite. I know my adjacent, so I'm thinking about O and A, so I'm thinking TOA, or tangent. So I think that the tangent of theta is equal to the opposite over adjacent. So the tangent of 35 degrees is equal to my opposite, x, over my adjacent, 12. I'm going to turn this into a proportion, so put tangent of 35 degrees over 1, and I'm going to cross multiply. That leaves me with x times 1, or x, is equal to 12 times the tangent of 35 degrees. So now all I need to do is type that into my calculator, and to 2 decimal places I end up with 8.40 centimeters.